Hello and welcome. Today we are going to analyze stock market data for ADANI using Databricks and PySpark. We will learn how to load data, clean it, transform it, and derive meaningful insights from it. I will also explain each output we get so you understand what exactly is happening at each step. So let's get started. The first thing we will do is upload our dataset onto the Databricks platform. So open your Databricks workspace and on the left hand bar, go to new and select table. And here you can see we get an option create a new table, and inside it there is an option to browse our file. Let's select our Adani dataset. You can download this dataset directly from Kaggle, and let's wait for it to upload. Now scroll down a little bit and you will see an option create table in notebook, and as you can see here it has opened a notebook for you with some pre with some overview and previously created commands for us. Well, we will not be using these, so let's just delete all these cells and create a new cell for ourselves. Let's also change the notebook name to Adani and select the language as Python. Also connect your compute, and this will take a few seconds. My cluster clone, that is the name of my compute. Now let's get started. So to load our data into a data frame, we will be using df function from Python. So let's first give the file path. So the file path in Databricks start with file store and tables slash adani.csv. That is the name of our file we uploaded. The next thing is df. So spark.read.csv, and here we will give the file path and header equals to true, and also infer schema equals to true. And let's display the first few lines. So let's break down what sorry, we have to write df equals to spark.read.csv file path. Let's run this. Let's break down what we just did. The file path specifies where our CSV file is stored inside Databricks. The spark.read.csv is a PySpark method that reads the CSV files. Here it is, it's showing our top 20 rows. The values are pretty big, so it's not very sophisticated to see, but you get the point. Header equals to true tells Databricks that our first row contains column names, and infer schema equals to true automatically detects the data type of each column. The output, as you can see, is the stock data with dates, price information, and trading volumes. So the highs and lows of that day, and the timestamp, symbol being Adani Power and Adani Ports, and everything else. So let's get to the next cell. Now we will perform data cleaning, which will be checking the missing values. So let's on the next cell. So let's run this. So it will show you how or which blocks have null and values existing, and we seem to have some issue. Let's me I have changed the code and ran it again, and you can see all the zeros in here represent that there is no missing values or missing null values. So this means that Adani stock dataset is absolutely complete. So there is no need for data cleaning. Sorry, no need to replace the missing values. Now let's move on to the next step. Let's still clean the data and let's run this code. This is pretty simple. This will drop the duplicates value. Now let's check our data size. So type the command, so query. Let's run this. So this will show us the original count and the clean count, which is equal. I just wanted to show you how to do the cleaning. As you can see, there are no clean records because there were no null values or missing data in our data set. Now let's move on to the next step. Let's fix our data types and timestamps. So I will be pasting the command here or the query here for you to see. Let me here. This is the entire code or the query to clean or fix our data types and timestamps. Let's run this. There seems to be an error. Here you can see I have updated the code, and let me give you what I have updated. So here I'm using from Unix time. This converts the Unix timestamps in seconds into a human readable string. The import is required to use it. So next is the double type. This ensures numeric columns have consistent double precision floating point data types. And schema check, using print schema to verify data types of all columns after the transformation. So as you can see our output, this shows that all our numeric columns are now properly typed as double and our time stamp is in readable format. Now move on to data transformation. Here we will add some useful metrics. The first is the daily price range. Let's type the query. Let's run this query, and there seems to be an issue. I have updated the query and you can see the issue has been resolved. The issue was because there was no date column in our data set, and I have now created that in DF. So as you can see from the output, this shows us the high and lows of each trading date. As you can see, these two are the same, and these are the dates. We have gotten the dates from the timestamp, so it's in some weird format, but you can get from it the highs and lows of each date and the price range. The maximum is shown, the minimum is also shown. Now let's move on to the next cell. Let me write the command. Let's run this. This shows us the daily percentage change in price, and the positive values indicate that the stock closed higher than when it opened. So you can see open at 537 and close at 538.59. So there is a percentage change. It's showing the only top 5 rows, and you can change the show 5 here to however many rows you want to print. Now let's move on to the next step. The next will be the analysis. His We will be doing some interesting analysis, and let's start with basic statistics. Df transformed dot describe dot show. So this will give us a statistical summary of our data, like the number of records, the mean average, the standard deviation, which is a measure of volatility, minimum and maximum values. Sorry. And now let's find days with high trading volume. And this will show us like what days the Adani stocks were highest traded. DF underscore scale high volume. Scale greater than. Let's run this. These are the top 20 rows showing that which days the Adani stock were traded the most. Let me zoom out so that you can see it properly. The percentage high, PT change, and price range. Now let's move on to the next cell. Now we will get the monthly trends. This will show us the average closing price for each month, helping us identify the seasonal pattern. Let me just paste the query and zoom in a bit. Let's run this. Okay, there seem to be an issue. Here I have updated the query. As you can see, the month function needed to be explicitly imported from PySpark. So, and you can see the result. This is the monthly average close for first month, January, it was 439, for February 420, and the rest. Now let's move on to the next cell. This will be the last cell of this session, and we will be looking at volatility. So TF, sorry, underscore equals to TF underscore transformed dot group by, and let's group it by symbol. Here dot G aggregate F dot STG, sorry, SPTD standard deviation close dot alias close ordered by F dot call, sorry, dot show. So let's run this. Now this shows us the standard deviation close, and it tells us about the stock's volatility, like how much the price typically varies from its average. As this was the last cell, now we will conclude. So what we learned today? We learned how to load and clean the Adani stock data. We added useful metrics like price range and percentage change, analyzed basic statistics and identified high volume trading days, looked at monthly patterns and volatility, and calculate the daily metrics like price range, which averaged around 10 to 15 points. Identify significant trading days like volume over 1 million shares, and track monthly trends in stocks performance. These insights can be helpful and can help us better understand the stock's behavior and market patterns. In our next tutorial, we will move to more advanced analysis techniques. That's all for this session. Thank you.